Welcome back, boys. We will do questions related to transformer. Textbook question number 7.23. Okay. A power transmission feeds input power at a 2300 volt. So input power we connect to input voltage, we connect to primary. So primary voltage is given VP 2300 volt. Step down transformer having windings 4000 turns. So primary windings is given. So what is the number of turns in the primary windings? NP 4000. What you have to find out, what should be the number of turns in the secondary? Secondary number of turns NS. You have to find out. To get output power at 230 volt. Output power we are getting at the secondary coil. So VS 230. So what is the equation? You have to use the transformer equation. Vs by Vp equals Ns by Np. Vs you need to find out. Sorry, Vs is given 230 divided by Vp 2300. Ns you need to find out divided by what is Np? 4000. So just to cross multiply. So Ns will be 230, 2310. So Ns will be how much? 4000 divided by 10. You get 400 turns. So this is the number of turns in the secondary. Now question number 7.24. A hydroelectric power plant. At a hydroelectric power plant, the water pressure head is at a height of 300 meter. Okay, so water is stored at a height of 300 meter from ground level. Water flow available is 100 meter cube per second. See the unit, a meter cube per second. That is the volume of water flowing out per second. 100 meter cube per second. If the turbine generator efficiency is 60%, estimate the electric power available from the plant. You need to find out the output available from the plant. Okay, so what will be given here? Water is at a height of 300 meter. So what is the energy, input energy? mgh only, right? So input energy, input, you take input power. What is input power? Energy by time. What is the initial energy? Potential energy of water. So mgh divided by T. Okay. Now efficiency is given. What is the equation for efficiency? We can represent by eta, 60%. You know the equation for efficiency? What is the equation for efficiency? Efficiency is output power. O bar P means output power divided by input power. I bar P is input power that we represent like this. So efficiency is 60 divided by 100, 60%. This output power you have to find out. What is the input power given? mgh divided by time. So output power divided by mgh. Here time is 1 second. It is given volume of water flowing per second. So time is 1 second. Okay. Now, what is mass? Mass can be written as volume into density. Okay. So now we can go further. 60 by 100 equals output divided by mgh. What is a mass? Volume into density. Okay, volume is given how much? 100. Density of water is 10,000, right? Now that is m only. Now mg, g you take 9.8 into h 300. Now you can find out the output power. So just to cross multiply 60 by 100 into 100 into 10 raised to 3 into 9.8 into 300. So you have to calculate. This will be the answer. Okay, that much watt. That will be the output power. So you will get 17.6 into, now simplify power, 10 raised to 3, 10 raised to 5 watts. Okay. This is the answer. Now we will do the question number 25. See, read the question carefully. A small town with a demand of 800 kilowatt of electric power at 220 volt is situated 15 kilometers away from electric plant generating power at 440 volt. See, there is a town. So demand of the town is how much? 800 kilowatt. Okay. So it should get at a 220 volt. So it is 15 kilometers from an electric plant generating power at 440 volt. See, here there is a generator. Okay. So town is at a 15 kilometers. This is a generating station. Left side I have drawn generating station. What is the distance between these two? Town and generating station? 15 kilometers. Okay. Now, generating station voltage is generated at 440 volt. Okay. The resistance of the two wire line carrying power is 0.5 ohm per kilometer. The wire has a resistance of 0.5 ohm per kilometer. Remember, town get power from the line through 4220 volt step down transformer. Listen, here electricity is generated at the generating station. You have to transmit it. Okay, for the transmission, you need to increase the voltage by using step-up transformer. So, power is generated at 440 volt. You have to increase it to a very large voltage. So, here at the generating station, I am using a step-up transformer. Step-up transformer. It is raising voltage from 440 volt to some high voltage, say X. Okay. Then it is transmitted. Then power flow, moves through the lines. And at the receiving station, at the town, what is the demand of the town? 800 kilowatt, but okay, there is a transformer. So at the town, electricity is reached at 4,000 volt. Okay. Then that is lowered to 220 volt using step down transformer. Okay. So this is what happened. So at the generating station, voltage you have to increase to a very high value. 440 to a very high value, say X. Then it is transported. At the town get voltage from 4,000, that has to be reduced to 220 using step down transformer before we take to the homes. Okay, and what is the demand? At the town, demand of the power demand is 8,800 watt kilowatt. So power reaching this point, 4,000 volt is given there. You can find out the current through the wires. So you know power equals V into I. What is the power demand of the town? 800 into 10 raised to 3 equals V. What is the voltage at the town? 4,000 into current. So you can find the current through the wires. So what is the current passing through the wires? You can cancel 10 raised to 3, 200 ampere. So through the transmission wires, how much current is flowing? 200 ampere. Now come to the question. First question. Estimate the line power loss in the form of heat. What is the equation for power loss? Power loss. I square R. Okay. I, you know. What is R? You know, R is the resistance of the transmission lines. How many kilometers of lines are there? 30 kilometer. Why? For transmission, you need two wires. Live wire, neutral wire. Two wire you need. So 30 kilometer is the length. So what will be the resistance there? 30 into, for 1 kilometer, what is the resistance? 0.5. So 30 into 0.5, 15 ohm. This is the resistance. Now you can calculate power loss. What is the power loss? I square R. What is I square? 200 square into 15. So how much you are getting? You will get this as 600 kilowatt. Okay. So 600 kilowatt is lost across the line. So that is the power loss due to transmission. Power loss. Okay. Now come to the second question. How much power must the plant supply? You know, During transmission, how much is lost? 600 kilowatt. What is the demand of the town? 800 kilowatt. So how much the plant must supply? See, if plant is supplying 800 kilowatt, 600 will be lost. 200 will be getting at the town. Okay. So how much the plant must supply? It must supply the loss to plus how much power is lost to plus demand, right? So what is the demand? 8,000 kilowatt, 800 kilowatt, right? Plus how much is lost? 600 kilowatt. So the plant must supply 1,400 kilowatt. Okay. So during transmission, power is lost. So the plant must supply how much will be lost, more you have to give. Demand plus how much you have to give. 800 is demand. So 600 will be lost. So power plant must supply 800 plus 600. I feel it is clear to you. Okay. Then third part. Characterize the step-up transformer at the plant. Listen, I told you at the generating station, 440 volt has to be converted into a higher voltage, X. That X you have to find out. Now you see, what is the voltage drop across the transmission line? See, at the town, voltage is 4,000. Plus, how much voltage is lost across the transmission line? We can find out V equals I into R. What is I? 200. What is R? You calculated as 15 ohm. So how much? 3000 ohm, 3000 volt. So across the line, 3000 voltage is lost. At the town, you should get 4000. So what will be the voltage at the generating station? Voltage should be raised to 4000 plus this 3000. So how much? 7000 volt. So at the generating station, you have to use a transformer 440 to 7000 volt step-up transformer. Okay, I think it is clear to you all. Then next question you have to do yourself. Okay, it is a similar question, only they change the numbers only. 7.26. That do yourself. See the question I will show you. See, do the same exercise above with the replacement of the earlier transformer by 40,000 to 220 volt step-up transformer. Here only difference is at the town you are using 40,000 to 220 volt step-down transformer. So do yourself. Okay, boys? So these are the important questions related to transformer from the textbook. Besides this, you have to practice board questions and the inside solved examples also. You open your textbook, there are inside solved examples that you have to practice. And this exercise plus board questions. Okay. If you have exam idea, you can practice from there, or you find online, or you do the worksheet I am sending. Okay, I have sent so many worksheets to you that all you have to practice and solve during this vacation time. Okay.